Thanks a lot, Tatiana, for these nice welcoming words. Yes, hello everybody. Stormwater management is on the menu today. And yes, I have the pleasure to guide you through our program today. What's coming? You can already see we got two exceptional great speakers involved. One hand, Heiko Sieker, who is Managing Director of Ingenieurgesellschaft Professor Dr. Sieker, MBH, and he is doing actually a lot of projects in Germany, also Honorary Professor for Urban Hydrology at the Technical University of Berlin. And second, Oscar Warmerdam, Chief Executive Officer of Sempergreen USA, who will also share very interesting experiences in relation to stormwater management. So how are we going to do this? What's the operational frame for today? So first follows a little introduction. We're actually already in the middle of it. We still have to ask, I think, some people to mute their microphones, please. Thank you. Then we are going to have one very short introductory presentation by myself. The second presentation will be Heiko. He will focus on stormwater management on a planning, civil engineering, and city perspective. And as our third speaker, Oscar will focus on stormwater management on a technological level, also going into details about the current offers companies have in that frame. After our presentation, 10 minutes for me, 25 minutes each for our two great guests, we will have a hopefully colorful discussion. We already have a lot of different opinions collected in the room. Oh, it will be tough. We will have fun, I'm sure. And of course, we are also going to answer questions that you may have from side of the audience. And afterwards, we are going to conclude, and Tatiana will send us home what's next with a set of new upcoming events that you may find interesting to join. Also important to mention, this webinar will be recorded. It will be available online also with free access afterwards. And it is thanks to our great sponsors, supported today by Ecostratos, Living Smart and Green, and Sempergreen. Thank you to our sponsors. So I'm going to start quickly about the EFB. You already know this slide, a lot of you who are following our webinar series. So the European Federation of Green Roof and Living Wall Associations was founded in 1997. We are a non-for-profit organization. Actually, we are the European umbrella organization for national green roof associations, of which we currently have 17 in 19 countries in our direct network. And of course, we have a lot of cooperations ongoing, for example, with the World Green Infrastructure Network, the European Landscape Contractors Association, the International Federation of Landscape Architects, our So Green initiatives, etc. If you're interested, please feel free to visit the EFB website or get in contact with us, of course, over our different social media channels or via email. Yes, my introduction talk, we already heard it. I'm from Austria. My background is actually landscape planning and landscape architecture. I've worked in research and also practice on especially green roofs and green walls, but I've also touched certain recent developments, like, for example, sponge city tree planting. We had a very large flood event in Austria over the past few months. You can see a picture here on the left. Yeah, basically a very huge area of Austria looked like this for a couple of days. It was a big disaster. Even people died. It took, yes, a lot of time, of course, to get all the water away again. And still a lot of insurance companies are obviously their cases open. And yes, what could be more interesting than this current time to talk about stormwater management and enhancing the power of nature-based solutions for stormwater management, different kinds of, and embracing maybe sponge city principles or a bit of a question. So this is a Chinese city that you see on the right side. It was actually, yes, reshaped by Kongjian Yu. Maybe you know him. He's like, let's say, the Pope of the sponge city, inventor of many projects and principles. So, and I think what we are going to talk about today will refer very well to actually these two pictures. Yes, what's coming now in my brief 10 minutes. So I'm going to do a quick overview for you on the European Commission terminology. Yeah, where do we find stormwater management currently? Then I will just pinpoint some related EU policies and directives in that context, where we also as EFB and on the national levels, people like you and all the people who are listening can actually do something about this and bring forward this important matter. I will focus quickly on what also national associations can do on their national scopes and levels in the current situation. And I'm going to close my quick overview with two related Horizon projects that are just about to close next year that I personally found very interesting and that I'm following because I think that they have quite interesting content. Yes, it all started a couple of years ago. European Commission, this is still a German picture, in the very, very beginning, published Eine grüne Infrastruktur, a green infrastructure for Europe. And starting with this point, actually, a lot of different concepts, regulations and policies have embedded. And you can already see that in this picture here are a lot of important components for stormwater management, because these are all solutions, different kinds of solutions. If we are talking about natural river reconstruction, or of course, green roofs and green walls, or also nature protection areas, or biological agriculture, sustainable tourism. So there is a lot of different activities that can come together in order to help water get treated on site, get into a natural water cycle on site, so that heavy storm events can pass without big damage. What else can you find currently? What I brought for you today is the new European Bauhaus program, because it's really interesting for how we are going to refurbish and shape buildings in Europe over the next few decades. The new European Bauhaus is kind of a quality program. It's for beautiful, sustainable, together ideas of how we want to live and work together, of course, in a safe and resilient way. So in that context, of course, nature-based solutions, NBS, play a central role in Europe. Nature-based solutions were already defined. They are inspired and supported by nature. They are cost-effective, simultaneously provide environmental, social, and economic benefits, and they help build resilience, which is something very important if we discuss how we have to transfer our landscapes, seascapes, cities through locally adapted, resource-efficient, and systemic interventions. Systemic intervention. The role of a green roof in a systemic intervention will be also the center of the talk of my two following experts. And what I also brought for you that some of you may not know already, but you could join. By the way, all these links that you see here and all the logos, you will receive also the presentations. If you ask the office later on, there are links, so you can directly just use this and enter to all these sources we're trying to get knowledge up to you. So nature-based enterprises are more or less a logic conclusion of what follows out of nature-based solutions. So a nature-based enterprise, and some of you are nature-based enterprises, use nature as a core element of their products or service offerings. And nature may be used directly by growing, harnessing, harvesting, or restoring natural resources in a sustainable way, or indirectly by contributing to planning, delivery, or stewardship or sustainable nature-based solutions. In order to bring us who are delivering, so the planners, the system providers, etc., together, the Connecting Nature Enterprises platform was established a few years ago already. It's a large growing community. So in case you're interested, I advise you to take a look and maybe sign up there. What else did I bring today in relation to stormwater management and the European Commission? So current drivers, we have a lot of interesting directives and national processes ongoing. So what you can see here, and as well, of course, click are the guidelines for member states for the adaptation strategies and plans. So basically a manual provided by the Commission for our national member states in order to successfully adopt to climate change. Then we got 4 different directives that I brought today. There are even more, but I just picked a few where I can see a direct link to what we are going to discuss today. So the first one would be the Urban Wastewater Directive. It currently has an open window that on national level, the member states have to establish their national integrated urban wastewater management plans until 2033. We will, of course, immediately see, okay, there are some people working on these plans. Now is the time we integrate nature-based solutions also on buildings, of course, like green roofs and walls, into these national plans. So if you get knowledge about people who are working on these plans, get in contact and be a good consultant for them. Second, the EU Nature Restoration Law, which has passed a few months ago. I must say I'm very happy about that. The nature restoration law as well contains measures for urban areas and cities when it comes, for example, to a certain degree of tree coverage. But also now members must prepare their national restoration plans and submit them until 2026. So just like the same with the Urban Wastewater Directive on national level, now there is a window of opportunity. A lot of experts may sit in every country where you're coming from and work on their national restoration plans. So in case you can help them out by integrating nature-based solutions, also especially for stormwater management, now would be the time. The third directive I've brought for you is the EU taxonomy. It basically regulates sustainable reporting and development for corporates. Of course, green on building is a part in that area because it helps to shape resilience of the building stock that these big corporates have. So if you want to engage on that level as well, I just listed 2 companies that are part of EFB national members, Greenpass and Gentian, who are also working closely with the methods of the Task Force of Nature-Related Financial Disclosures in order to really on-spot calculate and guide companies through this taxonomy process. So also here, there is a lot of potential to integrate stormwater management on building plots over the taxonomy law that our big corporates have to live from now on, not just report, but also have to live. And fourth, but not last, is the EPDB. A lot of you will already have heard about it, the Energy Performance of Buildings Directives. It includes the wording green roofs, and it is already in force, of course. So what we see on a lot of different national levels across Europe, that a lot of national bodies are currently working on renovation passport and also energy certificate for buildings. So also here is a very strong potential window of opportunity to get active and integrate nature-based solutions. So what else can we do on national levels as associations? I brought you just an recent example from Austria. What we can do, and this is really, really important, we can work on our technical national standards and guidelines for a seamless integration of green roof and wall build-ups that have a very strong performance in stormwater management, because most of our current standards and guidelines are not explicit about this certain performance of our technology. So what we are currently doing in Austria, we have a standard in green roofing since the year of 2010. We are doing an update currently this year, and besides biodiversity aspects and the integration of biosolar roofing technologies, we're also integrating enhanced build-ups for stormwater management, retention, staunch roof, the renaissance of the 0-degree roof, etc., etc. So that's quite a powerful move, and I see this also going on in a lot of our member countries. Yeah, what's next for standardization? Standardization is very important when we talk about stormwater management, because if the green technology is standardized, it's much easier to pick over the gray solution. Yeah, so here is a key element that quickly drives forward. Sorry, I have to ask you to mute your microphones. Tatiana, you help? Okay, great, thank you. On the other hand, of course, as you can see on this picture, and I think that's a very good pass for Heiko already, there are a lot of different other nature-based solutions that green roofs have to work in combination in order to provide full stormwater management from a citywide perspective or a city quarter perspective. So we are talking about not just vertical farming, garden roofs, lightweight roofs, staunch roofs, roofs for water treatment. We're talking about rain gardens. We're talking about sponge city tree planting, etc., etc. And also a lot of these technologies nowadays are as well not standardized, just as great technologies. So here also lies a lot of work in integrating closed water cycles, bio-based materials, prefabrication, ecology, to be honest, a lot of performance-oriented aspect of nature-based solutions. So, and this is my last recommendation before I open the floor for our first speaker. Second speaker, sorry. These are two ongoing Horizon projects supported by the European Commission that I found quite interesting. So they are both focused on nature-based solutions for water treatment. They are doing this a bit on different scopes and styles. So the first one is multi-source. They also work with demonstration areas and demonstration plots where they actually take their measures out. And in case of multi-source, for example, in Leipzig at the Umweltforschungszentrum, there is a big green roof test site for stormwater management, actually. And the results from this test site are implemented in the NAT for Watt management tool that actually planners will be able to use after the project is finished. They also try to engage and present the results of the project in specific policy briefs that can be also used very, very well if you, for example, want to inform a city or a police officer on suitable solutions that they could undertake. So these policy briefs are, of course, published on the website. And the second project is the NICE project, which is basically focusing a lot on green roofs and green walls as well from different aspects of water treatment. This project is very strong in its events, and it also offers a huge amount of webinars specified to certain NBS technologies. So I hope that was kind of an introduction on a European level. And now I'm really, really happy to announce speaker Heiko Sieker. And yes, the floor is open to you. And yeah, we're looking forward to a planner and a civil engineer guiding us through all the different tools and all the different aspects that are important and that we need in order to transform on a bigger scale, on a city scale, on a city quarter scale. So Heiko, I will end my presentation for now, and I would ask you to share your screen.
Yeah, thank you, Vera. Good afternoon from Berlin. Can you see my screen? Okay. So, well, I would talk about stormwater management between heavy rainfall on one side and heat stress and drought problems on the other side. And I do this from a Berlin perspective, because Berlin is in a few ways quite special. And I want to explain this first, because maybe then it's easier to understand why we do this, or why we follow this strategy in stormwater management. So as far as I know, Berlin is the only larger city in Europe which takes all their drinking water from within within the city border. We do not import water. That has to do with the historical situation. You know, there was a wall around, at least around the western part of the city. And if you look at other cities, Munich, for example, gets its drinking water from the Alps, Stuttgart from Lake Constance, and other bigger cities take it from the outskirts. So Berlin is different. It takes all the water from wells within the city border, and you can see our waterworks here. They are located here in the western part of the city and in the eastern part. Again, this has to do with the historical background of the city. And we have another, you can say, critical situation. Our wastewater treatment plants are upstream of the drinking water works. As a civil engineer, you learn at school in one of the first lectures that this is not a good condition. Typically, the waterworks is upstream of the wastewater treatment plant. However, in Berlin, this is different. Our wastewater treatment plants are upstream of the drinking water works. And this is causing, you can imagine, a kind of circulation. So all the treated wastewater, at least partly, ends up in the drinking water works again. So we already have in summer here around 30% of circulation in our water system. And in addition, we have, of course, like every other city, a large impervious area. In Berlin, it's around 100 square kilometers, maybe even a little bit more. And as you know, stormwater runoff, especially if it comes from streets and roads, is not clean at all. It takes up all the pollutions from the traffic, for example, and same from roofs. We have the roof material can cause pollution in the stormwater runoff. So the situation with the upstream wastewater works and the urban pollution that comes from the urban areas in total, it sets very high demands for water protection traditionally in Berlin. So that's something we are working on here now for many, many years. So our challenges here typically is about water pollution control. We have compared to other cities, a very slow flow in the rivers. And large areas are groundwater protection zones. So treatment is very important. Also treatment for stormwater runoff, for rainwater is very important. On the other hand, flood control, at least in the bigger rivers, is not so much a problem. So there we are in a relatively lucky situation. If you look to the River Spree and Havel, these are the main rivers here in Berlin, compared to the bigger rivers in Germany, the River Rhine, for example, the flow rate is very, very low. However, we, like other cities, we have problems with with overloading of the sewer system. So retention of stormwater is important, but not in a way to protect from flooding in rivers, but more what we call pluvial flooding. So and water cycle, of course, in general is also a problem. And that led already between 25 and 30 years ago, we had a change of mind in Berlin regarding stormwater management. This is here, the picture you see here of one of the first projects, which was built in the late 1990s. And it's quite interesting. It's quite a large residential area. And you can see all the buildings have green roofs. We have infiltration here, infiltration devices for the road runoff. And although this residential area is located very close to the river, there's no runoff. So all the water, all the rainwater from this area stays in the area, no runoff, and keeps up the groundwater renewal and so on. But it's important to see that the driving force for that was mainly water pollution control. Yeah. And we have very good experiences with that. So all the facilities you see here on these pictures here are more than 25 years old, mainly infiltration swales, also the green roofs. They are still in very good condition. And I think we can say that in Berlin, we have now a long-term, very good experience with the traditional stormwater management. What is really interesting is that these hydrological challenges changed a little bit in the last 5 to 10 years. In addition to this water pollution control challenge, we see now also a challenge regarding the quantity of water. Just a very quick, very simple calculation. If you take all the capacities of all the water works together, it's approximately 1 million cubic meters per day. On a hot summer day, here all the Berlin people, around 4 million, use 1 million cubic meters per day. And if you transfer the units, this ends up with around 12 cubic meters per second. So that's the demand for drinking water. If you look at the inflow from the rivers, these are the two main rivers here, Spree and Havel. Together they have 36 cubic meters mean flow. And you can imagine mean flow means that is the annual average. In summer, when there's a drought situation, the inflow from these two rivers is even much lower, especially here from the Spree. It's almost zero. And then the capacity of the waterworks is larger than the inflow from the rivers. And remember, we take all the water from what is created in the city. Yeah. So drinking water supply quantitatively is a new challenge for the city, and our authorities here in Berlin are very aware of the situation. And the big problem is that this gets worse to mainly three reasons. First of all, our population is increasing. We have a growth in the, for example, between 2008 and 2018. So in 10 years, the population increased by 400,000 people, roughly 10%. And if you look at the forecast, then all the prediction shows are showing further increase in the population. So, and that means, of course, if more people need more water, and they also increase more surface ceiling, around 1% per year right now. And then also the inflow situation is getting worse. First of all, due to climate change, but not only, it also has to do with the upstream catchment, which is shown here on this map. You see here the yellow area, that is Berlin, and the area shown in the picture is the catchment of the river. And there's a lot of coal mining. And as you know, in Berlin, we stop coal mining here until 2030, and which is good from the CO2 point of view. But regarding the water situation, that means all these open coal mines will be filled up again. So all the water in the catchment will go to the open coal mines. And that means that the inflow to Berlin is even going down in addition. And then climate change comes on top. And if you look at the predictions here for Berlin, it's quite interesting. It's not so much about the rainfall. The rainfall, all the predictions here, the climate modeling for Berlin shows that the annual rainfall is more or less stable, maybe a little bit going down. But what you can see here, our annual precipitation is already, at least for the, if you compare it with the German average, it's relatively low. We have 600 millimeters per year. And what is definitely increasing is evapotranspiration due to the global warming. And global warming means higher temperatures, and higher temperature means more evapotranspiration. That's obvious. And if we look at the climatic water balance, which is the difference between rainfall and evapotranspiration, it's already negative in Berlin. And this is increasing. So the deficit is increasing. And that means by definition, we already have what is called semi-arid conditions here in Berlin, which at least for Germany is quite new. Maybe it's different in other countries, especially in the Mediterranean area. You are used to that. But for German conditions, this is a relatively new challenge, I would say. So climate change will definitely intensify the drought problems. And this all adds up. Yeah, I mean, we have an increasing water demand on one side. We have reduced water resources, reduced inflow, and that means that the circulation we already have will be reinforced. Yeah? So we really are facing here big challenges in Berlin, and the city government is aware of that, and that's a good motivation here for the stormwater management, which I will explain now. Maybe some words also on the effects we can already see. So we have limitations in water supply. For example, myself, I'm not allowed to irrigate my lawn in summer anymore. I have restrictions. You know this from the Mediterranean area, you know from Las Vegas, for example. They have similar regulations. At least in Germany, again, this is new. And we also see the effects on the water courses already. A lot of the smaller water courses are dried out. Yeah, that's new. I mean, we didn't have that. 20, 30 years ago. This is a new picture. So we already see, due to climate change and the other factors, that the landscape is changing due to climate change. That's and not on a global level, but on a local level. That's really impressive. And what we also can see, the impacts on the urban green. We have a lot of trees in Berlin, urban trees, but many of them are in a bad condition. For example, here, if you look at this tree here, it's not in a good shape. I mean, Vera, I'm a civil engineer, so I'm not a biologist, but even as a civil engineer, I see that this tree is not in a healthy condition. And if you look at this tree here in front, it's already gone. So, and that's not just a single case. This is, I think what I read, that more than 50% of the urban trees are more or less affected by that. So in total, to summarize, we have problems with heat and drought. So our water resources, the stress on the water resources is getting worse. On the other hand, and coming back to the title of my presentation, like every other city, we have big problems with heavy rainfall. So if it rains, typically the intensity is higher than it was before. And we had one event here in 2017, which was really exceptional and which also create a was a mind changer for the city administration. We had 200 millimeters, in fact, in 10 hours. This is not as bad as in Florida, for example. But if you compare this with the design storms, for example, we use as civil engineers, this is 10 times the design storm. Yeah, so we have to deal with heavy rainfall also. Some pictures here. Our airport was flooded, our roads were flooded. Luckily, no people were harmed, but the damage was really very high, up to a couple of €100 million. Yeah. So if we summarize this, we face two challenges. In fact, on one side, we have too much water during heavy rainfall. And on the other side, we have not enough water during the drought period. This is amplified by climate change, for sure, but not only. It's also the urbanization. And I mean, if there's a good point, the good point is that, I mean, we locally, at least locally, to change or to influence climate change is very difficult, as you know. But regarding the urbanization, we can do something. I mean, that's city planning. Yeah, that is in our hands as civil engineers, as landscape architects, as city planners to do something. Yeah. And so what is the response? And it's definitely not the conventional way of dealing with stormwater. I mean, it's so logical. Our previous practice, what I learned at school when I studied in the 90s, it was very simple. If you have a new residential area or a new commercial area, you need a sewer system, a storm sewer system. That was the only answer to that. And so we built a lot of pipes, and yeah, as you can see on the pictures, we trained our rivers, we built big concrete retention ponds, and so on. But I mean, even if you think that you can cope heavy rainfall with that, it's very, very obvious that the other problem, the drought problem, is not getting better by this solution. So the solution is to deal in a different way with the stormwater, getting away from drainage with end of pipe treatment towards a more sustainable stormwater management based on the local water cycle. Exactly, Vera, what you explained in your contribution. And I think from the Berlin perspective, we can really say that we started to implement the Spawn City concept now in every project, and that's quite, I think, at least on the in Germany, quite unique. There are many cities which have good pilot projects, but Berlin is far above the level of pilot projects. We do this on a frequent daily routine base. So we implement all kinds of Spawn City elements, I would say. Again, for those of you who are not so familiar with Spawn City is not a single technique. It's more like a philosophy, I would say, to deal in a different way with stormwater, and it's an umbrella for a lot of different techniques. And you can see here on this picture here different types of Spawn City elements: green roofs, for example, open ponds, pervious areas, rain gardens, green walls, swales, and so on. And we are now in the situation that in Berlin, as I said, we started 25 years ago. One of the big projects, by the way, was the Potsdamer Platz, which is our central square in Berlin. The pond you see here in front is part of the rainwater management system. It's fed by the runoff here from the buildings in the background. So this is not a natural lake. It's an artificial pond, a part of the stormwater management system. And I already mentioned or showed a picture of this Rummelsburg Bay. This was I think the best example we created 25 years ago. And you have seen this picture before. All the buildings got green roofs. We have, and this is a very important element, in the yards between the buildings here, there's a underground parking garage, and they get a green cover. And on the green roofs we have, it's more like an extensive green roof, between 6 and 8 centimeters, not more. But here in the center, where's an underground garage underneath, we have between 80 and 100 centimeters. And that is, in fact, the best storage you can create for stormwater. It's very easy, it's very cheap, also due to statistical reasons. And only the remaining overflow of these green roofs then finally is infiltrated. So although we have here 90% of coverage with building and streets, so that there's not much natural ground left. However, we do not have surface runoff. So it's not the surface seeding which is creating the problem. It's the way you deal with the runoff from the impervious areas. And to show you in practice how it looks like, again, this is the one of the buildings, has an extensive green roof, and you see here the this courtyard here with the underground garage. You can see here on the right side, and on top there is a soil layer of approximately 80 centimeters, and this little pipe here, the diameter is only 2 inches, so 5 centimeters. And to this pipe, an area of 2,000 square meters is connected. So, and that is stormwater management. This is a sponge. Yeah, it's so simple, in fact. Yeah, and you see here from the date of the pictures, these facilities are more than 25 years old, and I can all invite you, if you ever are in Berlin, visit this area. It's very impressive to see what's going on. We also have larger, what we call pocket parks, which are, first of all, green spaces, but in a secondary purpose is always to store stormwater, especially during heavy rainfall. And with this experiences, good experience from now almost 25 years, a couple of years ago, especially after this heavy rainfall we had in 2017, the city introduced new regulations for stormwater drainage. And that's very interesting. If you build a new house in Berlin, you are not connected. You're not allowed to connect your building to the storm sewer system anymore. Even if there is a stormwater pipe in the street, you're not allowed to connect. Yeah? And that's unique. So the city is doing this in a very straightforward way. We have building regulations. All buildings get green roofs. Every zoning plan, every Bebauungsplan, how it is called in Germany, at the very beginning of the planning process, we create a stormwater management concept for every project. And currently we have about 1,400 zoning plans in development in Berlin. So it's a very comprehensive way to deal with this stormwater here. Also very interesting, the city created what is called a rainwater agency. It's a group of civil engineers. They are now part of the Berlin Water, which is the operating company here of the water system, and they are offering consulting to all the housing companies, for example, but also to private people. So whenever you have a question here in Berlin regarding stormwater, you can call the Regenwasseragentur and they will help you out. So, and that's also, it's not just a technical issue. It also has a lot to do with regulations, but also with support of the people. And that's implemented and it works very well. So as I said, we have a lot of projects here in Berlin going on. This map here shows only the really big ones. And you see here, Neue Stadtquartiere means new city development areas. And the big red circles here means here new city districts are created with 5,000 apartments and more, 5,000 housing units or more. So these are really, in fact, new parts of the city, and all of them are developed following the Smart City approach. So we are not just doing some pilot projects, it's really mass production, you can say, here. And of course, we gain a lot of experience. And at the end, I want to show you one actual example, one of the housing projects we are working on here at the moment. It's yeah, for for Berlin standards, it's I would say mid-size. It's not the biggest one. 16 hectares, about 900 housing units. You see here the city plan, master plan for this area. And as I said, from the very beginning, starting with the development of the zoning plan, in parallel, we worked on a stormwater management concept. And in this case here, it's very interesting because we implement quite a lot of different technologies that has to do with the soil conditions, with the topography. For example, we have pocket wetlands, we have bioretention swales, optimized tree pits, and of course also green roofs. And very special here is what we call a multifunctional area. In fact, it's a landscape park, which receives the overflow of the other elements. So from the green roof, for example, in winter, you have still, even if you have an intensive green roof, you have a little bit of runoff, and this is discharged into the landscape park, which you can see here in this area. You see that this picture is from last year. The first buildings have been erected here. And this is I think this picture is from May or so. You see the landscape park is already in place. These darker green areas here, that are the retention areas. And all the runoff here, the remaining runoff from the green roofs, from the bioretention swales and so on, finally flows here into this area. And although we have loamy soil here, it's not a sandy soil, it's a loamy soil. We have no runoff at all. All the water stays in the area. So it's I think a very good example. And again, whenever you are in Berlin, you are invited here to contact me, and it would be a pleasure for me to show you around. Thank you for your attention.
Wow, thanks so much, Heiko. That was really a very, very interesting talk, and it shows how important it is to look at the scale and scales. Yes. Great. Thank you also for keeping the time. I would still ask all our participants to put their questions in the chat that we can collect them for later when the three of us are going to join together in a very strong and intense discussion. Yes, and then I would say we're going to dive deep immediately. Oscar, are you here already? Yes, Oscar is here. We can see his face. Can you please try and get your presentation on the screen?
Yes.
Thanks a lot.
Oh. Is time for a question?
Oh, sorry, please put your questions in the chat. We are going to refer to them once we finish the presentations. Okay? Great.
Almost there.
So Oscar is joining in from the US. He has a lot of experience also on product level and product development level on the roofing and the wall side. And yes, he will give us the newest tech update on green roofs for stormwater management, if I'm not mistaken. The stage is yours, Oscar.
Thank you, Vera. Thank you for that introduction. Yeah, my name is Oscar Warmerdam. I work with for Sempergreen USA. Sempergreen USA is a company that has green roofs and green walls all over North America. And I just wanted to tell you a little bit about our story here for the last 16 years or so, what we have learned about stormwater, and what kind of opportunities there are here that might also be replicable in Europe. As I mentioned, we have done thousands and thousands of projects, and much of what I will be talking about is something that is based on very localized knowledge. Whenever I see presentations about green roofs, somebody from the UK comes to the US and says, well, green roofs ought to be done differently, just like we do in the UK. Or some American comes to Europe and says, oh, you're doing it all wrong over there. You got to do it the American way. Most often those people don't have a clue of what the impact is of the local climate. So whatever the majority of what I say should be applicable in your market, but just make sure that you compare our climate to your climate just to make sure that that it is compatible. A quick overview of the difference between the two markets, the EU versus the US. There's a big cultural difference that Europeans tend to prioritize the environment. What's good for the environment tends to have a top priority. And in the US, we tend to prioritize costs. So the ideal is there of a green roof, for instance, or a green infrastructure. But if it costs more money, then very often it gets vetoed and they resort back to gray infrastructure, pipes and tanks. As a result, Europe installs about 15 million square meters of green roofs a year. And in the US, even though we have much bigger buildings, the annual installation of green roofs is approximately 1 million square feet. So that's just a fraction of what it is installing in Europe. Climatically, I would say the northern, and I'm making a generalization here, but the northern European climate is much easier to grow plants. It's much more difficult to do it in the US. And therefore, in the US, we have thicker profiles. We tend to do that with about 10 centimeters of soil as a minimum. Very often 15 and sometimes even 20 centimeters. And our colleagues in the Netherlands very often do green roofs that are 3, 4, 5, 6 centimeters thick. Because the systems are thinner and the market is so much bigger, the cost of a green roof in Europe is a fraction of what it is in the US. Roofs in Europe can be installed for maybe 60 or 100 euros a square meter. And in the US, that same square meter, albeit a lot thicker, would probably sell for about 200 to 400, maybe even 450 euros per square meter. So that is one of the explanations also why we sell fewer green roofs in the US than we do in Europe, because it's a much bigger capital expense. Because of the climate, our maintenance costs are higher. Weeds grow so much faster, and they grow so much faster on thicker profiles. So if you have a thin European, let's say, sedum roof, that is very hostile to most weeds. So the maintenance program requires you to basically service that roof 2 or 3 times a year. In the US, we service roofs about 5 or 7 times a year, just because the weeds grow so darn fast in those deeper profiles. If I compare our company compared to the European company, then the Europeans have difficulty keeping up with the growth of the market. So production, how to get more square feet of materials out there is their challenge. And for us, the challenge is how do we grow the market? How do we go from 1 million to 15 million? And that is basically the theme of this presentation. How can we can convince more building owners or developers to prioritize green roofs? Now, a lost opportunity, I believe, when I travel to Europe, and I've been to a lot of different countries and looked at their green roofs, is because the emphasis in the European market is very often on the cost of the system and the green roof I'm talking about. And the system is very loosely specified. Very often it just says green roof, 5 centimeter. And that is completely different than in the US. In the US, all the layers are specified, and every one of those layers has a very specific duty. So it's more performance driven in the US. And I very often I look at certain roofs in the Netherlands, and I go like, wow, if you would have spent an extra $10 or $20 a square meter, you could have kind of doubled the effectiveness of that green roof. So that's a somewhat of a criticism, I guess, if I look at the European system. On the other hand, here in the US, we're focused on a lot of proprietary materials, what makes the green roof very expensive, and that hurts our economies of scale. So that gives you a little bit of the sense of what the difference is between those two markets. In 2016, we started building this laboratory in Culpeper, Virginia, which is about an hour southwest of Washington, D.C. It's a very beautiful climate. The sun always shines over here, just literally, except for, the 1 week that we have hurricane weather. But this is a beautiful climate. And this laboratory was built with the intent of truly understanding the hydrology, the movement of water in a green roof. The industry has been relying on FLL type performance statements, so a drainage layer as a FLL test in order to establish how much water does it hold, as well as the soil and layers like mineral wool. They all have static tests that will tell you how much water that those systems can handle. Most of those tests are built to predict what the maximum weight of that roof assembly will be, worst case scenario, so that the structural engineer has a number to work with. They really don't give a truthful picture about how much water is available to the plant or how does it perform on an annualized basis. So our first objective was to fully understand, okay, when it rains, can we reach those FLL numbers with rainfall? And in case we don't, what is the reality? And it turns out that FLL overstates the retention capacity of a green roof rather substantially, because the test is being done in you take a canister of soil, you drop it in water, and that canister is pressurized from all directions. And rain is not pressurizing the roof. Rain is just water that falls on a roof and it finds its ways to the bottom of the green roof. And it usually is about 70 or 75% of what FLL promises. So we thought this would be very valuable to civil engineer. And we went to the first couple of engineers in the DC area. And we said, hey, we can quantify exactly what a green roof can retain truthfully by an actual test. We planted, as you can see one of the photographs, we planted these systems 1.20 meters wide by 8 meters long. And we thought this was really exciting for an engineer. And these engineers were like, yeah, this is really interesting, but it wasn't going to change their perspective on when to deploy a green roof. And this one engineer actually says, like, Oscar, the green roof industry always looks at things from dry to wet. So you basically say, the cups are empty, the mineral wool is dry, the soil is dry, and now it rains. And look how much storage capacity or retention capacity I provide with my green roof. And it's like, yeah, that's exactly right. We can add more soil, more mineral wool, bigger cups, and then we can improve these systems. But then it became clear that they basically, as we look at from a dry situation to a wet situation, they tend to look at worst case scenario and say, well, what if it rained yesterday and everything is fully saturated? What can the green roof do for me now? Well, and that kind of stumped us a bit, because we went back to the laboratory. We, over the last, 8 years, we literally pumped over $1 million in this whole research project. Sounds a bit insane, but every year it's a little bit, and it becomes a large number. But we rebuilt the laboratory once again, and we started looking, is this engineer really correct? If a green roof is fully saturated, does the water move vertically and then into the drainage layer and then horizontally off the roof really as fast as they claimed? And the result was exactly as they predicted. A fully saturated green roof, if it gets resaturated with another rain event, delays the water for about 4 or 5 minutes. And that's really not a lot. So that doesn't mean that green roofs are not functional, they don't serve a purpose. It just means that they have an incomplete purpose. So that they solve most of the rain events, but not all of the rain events. So when you look at most cities, so to make sure that we understand what a storm event is at least in the US, defined as a rain event that is followed by a 6-hour long period of no rain. So a rain event can be 20 minutes, but it can also be 3 weeks long, as long as there's no period of drought or dryness in between that is 6 hours or longer. So when we look at most Northern European cities and in most North American cities, there's about 100 large rain events per year. It usually varies between 90 and 110. So let's say 100. About 80 to 85 of those events are small and medium storms, and they are actually very well addressed by a green roof. The green roof seems to be able to absorb almost all of those rains, because the majority of the rain events are small to medium rain events. It's the last 10 to 15 rain events that are the really, really large ones, or the really, really long storms. So there's not that much water coming out of the air or out of the sky, but it just rains for a week straight. So those events are only about 10 or 15 a year, but they tend to produce about 40% of the annual volume of the rain. And those 10 or 15 storms, so only 10 or 15% of the rain events, is what's causing the flooding of the sewer overflows. Now, so a green roof is offering retention capacity, and this picture of this old-fashioned coffee apparatus, I don't even know what name to give it. My grandma had one of these. Every day when I present, I ask people, like, does anybody have one of these? And so once in a while you have this a person that says, yeah, I have one of these, but normally everybody has moved on from this concept. But I can imagine you can figure this out. You pour water into the top, and the coffee grounds absorb that water, and once fully absorbed, it starts to release water. So the water that is in the filter in the coffee grounds, that is considered retention, and then the water that fell through that in excess of the capacity for that coffee to hold onto the water, that water is called detention water. Now, the blue retention water is going upwards. That can only leave the system. I'm generalizing this a little bit, but it leaves the system upwards in the form of vapor. So the plants and the soil evaporate that, and it escapes the system upwards, and it's removed from the sewer. And detention water is actually very problematic. That water is actually, flying through the sewers and trying to escape the city. And if it cannot do that fast enough, it will cause flooding. So the goal is of a development, and as Heiko was mentioned, it's pretty similar here in the US. If you own a property, you need to retain and detain all of the water that falls during a certain rain event. And if you don't, so you're not allowed to dump water onto your neighbor's property. It's very simple. So the retention amount of a green roof is fairly well defined, and the detention amount is basically one of the shortcomings that we believe we can turn into an opportunity as an industry, so that we can justify green roofs as an even more effective tool and get more people to adopt them. You all know that so retention helps prevent these sewer outfalls. I think you've seen these pictures probably hundreds of times over the last number of years. But I'm always surprised that the public doesn't know this. When I ask people in New York or Washington, D.C., it's like, do you know what these big pipes are for? And it's like raw sewage, like literally whatever you flush down the toilet comes out of these pipes every time it rains more than a centimeter in New York City. There are about 30 overflow events in Washington, D.C., and I think we have about 180 of these pipes. So this is like kind of literally a dirty secret that the public doesn't seem to know about. But, green roofs, traditional green roofs, help fight this particular problem. And that's why in the US, at least, the civil engineers and policymakers, they don't call green roofs stormwater management tools. They call them water quality tools. And by defining them as a water quality tool, it actually it kind of cleans up, and it clarifies a little bit better of what that purpose of the green roof, traditional green roof, is, and what its limitations are. So a 1-inch design storm is roughly 2.5 centimeters of water, is roughly the target that a a US green roof needs to be able to absorb from a dry to wet state. The problem with what I mentioned earlier on with the FLL approach, there's nothing wrong with FLL, but by using only static values, by basically saying like, well, if we make the sponge as big as possible, or if we put a bucket, a meter deep bucket on the roof, and we just create a swimming pool on the roof, does that help? And what you really see is that retention is really a function of evapotranspiration. So if you think of of a bucket, of an empty bucket that is a meter deep, and you have a meter of rainfall, then you would think like, well, on an annualized basis, I basically within 1 meter bucket, I can absorb a meter worth of rainfall, and there's no runoff. So if you start with an empty bucket, that is true. But if you start January 1st with a bucket that is full, like what the civil engineer was suggesting, then on the only way more water can enter that bucket if water has left the bucket to begin with. And evapotranspiration is the way to empty the bucket. So a green roof is like a bucket. And the performance of that green roof is driven by wind, temperature, humidity, and of course rain and sunshine. So those 4 of those factors are basically telling you the output, how much water evapotranspires, and one of them tells you how much water falls in. So we believe that looking at these things through a modeled perspective is much more interesting, and it adds a tremendous lot of value to justify a green roof. Now, over here, and this is the only heavy slide that I am going to introduce to you. So I apologize for that. But this is what an engineer, a stormwater engineer, would look at regularly. On the top, the upside down graph, which is right over here. This upside down graph basically shows you, this represents the rain. So this is the intensity of the rain. The deeper that spike falls down, the bigger the rain event is. And as you can see over here, this was probably like 1 rain event, 2, 3, 4, 5, maybe 6 rain events. So even though it looks like a lot more spikes, they would consider this about 5 or 6 storms. There are, and this is a model. And by the way, these models, we have proven in field testing that these models are about 95, 96% accurate in able to predict how much water is being retained and evapotranspired off a green roof. So these things are extremely accurate, much more accurate than we ever would have thought possible. So there's a plain roof, a bare roof, the naked roof. There's nothing on it. That is represented by the gray bars. So as it rains over here, the roof immediately responds with runoff. And there's a bigger rain event over here, and as you can see, there's a bigger runoff. So there are also 3 green roofs. One is a traditional green roof, which is the blue dotted line. One is a sponge roof, which is basically an upgraded green roof with more water holding capacity. And one is a detention roof, or what we call a purple roof. But conceptually, just think of it as a roof that holds water, that retains and detains retains and detains water.
Não, se calhar não dizemos nada.
So as it starts raining, the bare roof immediately releases that water, and at a certain point, you see that the traditional green roof starts to follow that exact same runoff profile. So, and this is very often. So what you can see here is that the small and medium storms, the green roof was very well able to address. But as soon as that roof was fully saturated, it followed the contour, and there really is only about 4 or 5 minutes worth of peak delay, which is not even noticeable in this graph. Then because the sponge and the purple roof had more storage capacity, they didn't release water until this moment. And then all 3 roofs basically started releasing water just about at the exact same time as the bare roof. So at this point, there is no benefit to any of those green roofs because we've had all of these rain events in a row. Now, by adding a detention capacity, so adding layers underneath the traditional green roof that hold that extra water, that water that was in that glass canister, to hold that back and keep it underneath the green roof, we can basically show a completely different line. In this case, we had to reduce the outflow by 60%, but we can reduce it up to 95, 97%. So we can more or less, take this rain, this outflow peak and just drop it flat and extend it instead of making that a half-hour outflow. Rooftop detention can make that 24 or 48 or even 72 hours. Then and because it's released slowly, it's doing it over a much longer period of time. So you can see this took a whole day longer. A couple of days were in between, really nice weather. Actually, the system evaporates a lot of water during those next few days. And you can see that as it rained again, which is over here, you can see that the bare roof immediately started releasing water 3 days later. But all the green roofs basically were able to fill up that amount of storage capacity that was available because of 3 days of beautiful sunny weather. But then it repeated itself and it became the same as the bare roof. And here again, you see that a detention-oriented roof can knock down that peak and spread it out over a much longer period of time. Now, why is that relevant? A building owner can, or a designer, I should say, a civil engineer, has about 4 places where they can retain and detain the water. So when you think of, when you look at your iPhone and you look at the storm coming in, the green and the yellow and maybe the orange are your small and medium storms. And those, can usually be easily retained by a green roof. The big storms, the red and the purple, in the US, it is literally per 1,000 meters of roof area, we fill up an ocean container full of water in less than an hour. So we always show people, okay, if you have a roof that is, a multiple of 1,000 square meters, then multiply that times as many ocean containers, and that shows you how much detention storage we need on the property to deal with that big storm. Now, that storm can be put on the roof. We can put it in the driveway underneath. We can put it in a tank underneath the building or underneath the soil or underneath the garden. Or we can do that as a bioretention, or we can put it in the landscape. So those are the 4 options. Now, usually this is the cheapest. The landscape is usually the cheapest. The tank is usually also very affordable, but the tank doesn't clean the water. So that usually has a water quality concern that has to be resolved. And the roof used to be able to only retain water, still needing a tank, but we can also now upgrade the roof and then basically take this tank portion and place it on the roof and hold that water over there until 24 or 48 hours later. So here you can see, those alternatives a little closer. Heiko was talking about the successes of bioretention, and this is probably the best solution if you have the space at grade. This is the cheapest and probably the best solution. Permeable pavement, which is just, surface area, paved area that lets water go through. That doesn't clean the soils, doesn't clean the water, pardon me, and it's actually fairly expensive. And then, of course, you have these underground tanks. So those are the alternatives that we compete with when you're talking about rooftop detention. This is something that you are very familiar with. These are basically more or less milk crates or physical structures on a flat roof. As water basically saturates and oversaturates the green roof profile, that water falls into this lower area where special drain restrictors are allowing it to flow off the roof over a period of 24 to 48 hours. The tricky part is that this can usually only be done on flat or relatively flat roofs. And in the US, at least 90% of the roofs are sloped. So in the US, we have a slightly different approach. For the sloped roofs, we basically, and also actually in Europe, we do this as well. but the bottom two layers over here, the detention layer and the honeycomb, is actually the two areas that store the water that through the green roof and that prevent it from flowing out faster than 24 to 48 hours. So upgrading the green roof allows us to do a couple of things. I realize I'm a minute over, so I have 2 more slides. Modeling a green roof can be done in multiple ways. We have a proprietary system. The HydroCAD is a system that most civil engineers use. SWIM is what most policymakers are using. New York City has a very simple Excel sheet. But by modeling a green roof and using rather complicated ways of calculating their annualized behavior and dialing them in so much that they can be replacing the tank or the pipe or whatever else at grade that they don't have any space for, and then the green roof can have 2 functions: retention and detention. And in this particular case, this building owner in Toronto, it's a building that is roughly, half an hectare. And in red over here, you can see the dimension of the stormwater tank. So the stormwater tank is only there for detention. So that's the water that comes off the roof in excess of the retention capacity of the green roof. They still needed a tank that actually occupied 9 parking spots. Now you might think like, well, why don't you just go deeper and put the tank underneath the parking spots? Problem solved. But the tank has to be above the sewer pipe. So the tank always has to be, let's say, within the first 2 or 3 meters of soil depth, because it gravitationally needs to fill up the flow into the sewer. Anyways, these 9 parking spots generate in Toronto about $22,000 a year in parking fees. So there was $180,000, or a little bit more actually, was lost in stormwater detention. And note that this tank is only filled up about 10 times a year for about 24 to 48 hours. What a waste of space that was. So by putting a rooftop detention system, a green retention detention system on top of the building, we were able to vacate those 9 parking spots. And the payoff was basically 3 years. So within 4 years, an $800,000 upgrade was paid back in 4 years and allowed the client to put a green roof on top of the building instead of completely foregoing one. So that is our argument for green roofs. In many areas where they are required, it's great. That's a good market. Can't complain. But here in the US, the majority of the cities don't have that requirement or compliance requirement. And the only way that we can get a green roof on top of that building is to make it work and to create a real return on investment. And detention is a much better financial tool with much bigger consequences than retention. Thank you for your time.
Thank you, Oscar. Thank you for this comprehensive insight on what the industry is currently doing. I would suggest that we just maybe quickly pick up some questions for better understanding that came up during your talk, and then we also do this for Heiko, and then we get a bit into discussing. So I think we had a question to Oscar. The question was, what's the mean annual precipitation at the test station?
I mean, in Culpeper, Virginia, we get about 44 inches of rain per year.
Okay. Now we have to calculate.
Oh, sorry, a meter 10, and that is very typical for much of the East Coast, from Atlanta to Boston to Chicago. That triangle is roughly getting about a meter 10 per year, but we get it with buckets at a time.
Thanks a lot. So then there was another question, which was, so what happens to the water in the detention area how is it brought to the plant roots and evaporated?
So the upper layers of a detention system are the exact same. It's basically soil and maybe an additional layer of mineral wool that increases that sponge capacity. So whatever water is retained in those layers remains in those layers and gets used up by the plants. The water that fell through is going to go to the sewer. It's just going to go into the sewer at a much later date and at a rate that is allowed by the city. So when we have a project, the engineer will tell us what the allowable outflow rate is, and we have to meet or exceed that outflow rate, stay below that outflow rate.
Okay, thank you. If there are more questions incoming, we will let you know.
Thank you.
No, still, I think we got another request. A request for cooperation, Oscar. One of our listeners, Martin, would like to cooperate with you, and he's asking you how investors accept the price calculation of water retention.
Now, the water retention. So, you know, it's really a very site-specific little calculation that we have to run every time. So we have this very simple, it's a web page where we enter some values, and then we just basically say, well, what's the cheapest way to retain the water, and that's usually always the landscape. And what is so if a building has enough space, for us at least, the assumption is always next to the building is the cheapest. If the building doesn't have that space, then the roof becomes the next best choice. So, and this we calculate the numbers for the client, and we give them approximates so that they conceptually they can understand a little bit better how this works. You know, with all due respect to like the civil engineers have an extremely complicated job to do, and they at least in the US, you can see that they operate in such a complicated world that the design community has no idea how that all works. So you have these two skill sets that are separated, and we are trying to kind of be the bridge to simplify the matter, to give them some budget numbers and some performance numbers, so at least the conversation can go either left or right. And and architects and landscape architects, they tend to kind of get lost in the woods, and we try to simplify that and then hopefully steer them in the direction of nature-based solutions.
Thank you. It reminds me a bit of the talk we've had initially in preparation of this webinar about landscape architects and architects being involved or not. I think Leon just posted a question that also goes well together with some question I have seen earlier. So I think it's, if I understand right, a bit about a tech talk on soils and substrates and their water cleaning and purification effect. I think you both touched this a little bit. I think it's a very important topic because this is actually because of concerns for basically groundwater and also drinking water protection. If we're using nature-based solutions of the kinds we've seen today, what kind of water quality comes out of them? How does the soil or the substrate in the green roofing world, we're actually most of the time speaking about substrates and not soils, have to be built that they offer this technical filter capacity. I think that is, yes, a kind of summary we've got here. So, yes, would you maybe like to comment on that a bit, Heiko or Oscar? Who wants to go first?
Go ahead, Heiko.
Yeah, thanks. Well, I mean, there was also one comment in the chat that about healthy soil, and I fully agree with that. I mean, the best treatment you can get is by percolation through a layer of healthy, or call it activated, or however, a healthy soil. So, and that's what we do. For example, if we talk about bioretention swales, we build them by using natural soil. And only, for example, we have filter units for road runoff, where we try to clean the road runoff in a very small area. Then we use substrate, special substrates, and there are different mixtures with. It also depends on the kind of pollution. So if you deal with heavy metals, you need different type of material than, for example, if you have problems with phosphorus, then you would prefer iron to remove it from the runoff. And if you have problems with too much salt in the runoff, then you have almost no possibility to get it out, to be honest. So salt, in fact, is a huge problem. And the best way to deal with salt is to avoid salt as a de-icing material.
I think that was a very good and comprehensive summary. I think, I don't know, from my perspective already, I mean, green roofs are offering a filter and cleansing function of preparing water for further use already since a lot of years. I guess also in a lot of older German projects, just like in the Austrian ones, green roof excess water is used to flush toilets, for example, on larger plots, which is not the big deal, but I think nowadays, of course, a lot more treatment and purification functions are wanted from our systems. So by the way, these two Horizon projects that I mentioned earlier are both focused exactly on these aspects. Yeah, and both projects are trying to work on standardization methods for nature-based solutions for water purification and cleaning. Which goes more into basically integrating wetland concepts also on roof scales, etc., which is actually a service a good bunch of engineering companies and system providers already have present on the market. Oskar, would you also like to talk about maybe substrate and their cleaning effect? Would you have something to yes, also adjust and tell us in that context?
Well, the green roof is receiving clean water, assuming the rainfall is fairly clean. It tends to, as a green roof is freshly installed, it tends to pick up some of those minerals during the first and second year, and then usually after that roof has been settled in, then the water coming in is similar to the water going out. That's different with bioretention. Bioretention is receiving a whole bunch of dirty water from the parking lots and the roofs, and that is filtered by a bioretention system. So the water quality is not an issue for us with green roofs. Not a discussion point, I would say.
Yeah. Well, I can add that we had one case in Berlin where there was a special kind of I call it root protection lining. I don't know the right term for that. So it's to protect the roots from a green roof to somehow destroy the cover of the roof. So there was used a lining which was treated by called macropop, so an biocide. And so we had big problems with the runoff from the green roof. Yeah. Because it was contaminated with biocides. So that's not a treatment issue. It's a material issue, I would say.
Yes, but this is also an issue of the quality of the waterproofing. So we have a lot of different waterproofing products on the market. There are different ways of making waterproofing root proof, as we all know. There is a history in what you just mentioned, Heiko, but I think also there has been a lot of European Commission policy over the past few years that I think also went a lot on national scales. At least in Austria, we've seen this, and it also goes to biocide-free waterproofing, which is of course logical, especially when we are talking about really staunching basically water, reusing it for different purposes. then this is, of course, at least as important as the quality of the waterproofing itself. Yeah. You also mentioned, Oscar, normally we have a lot of roofs with a certain slope to guarantee a certain a certain speed of drainage, which is also mainly coming from the waterproofing industry that wants their waterproofing as water-free as possible in order to make sure it doesn't leak. So there is a lot of development in that area too, I think. So what's your maybe what's your attitude to waterproofing, by the way, Oscar? And if you're staunching basically the water on it, do you have specific waterproofing products or companies that you're working with that are basically preparing your roofs for greenery?
No, we basically supply anybody with a membrane. But what blows my mind always is that people put a 15-year warranty membrane underneath a green roof that can be there for 50 years. So it blows my mind that you don't want to put a really high quality waterproofing system underneath the green roof. So you can probably get 50, maybe even 70 years out of it. The oldest roof in the US that we have that is green is a Rockefeller Center that is over 76 years old and has never been re-roofed. And that has been covered with about a meter with the soil. So that's the only comment I have, is I don't understand why you would put a discounted membrane underneath a roof that,
this is a bad plan. Yes, we know.
Bad plan, yes.
So actually, I think summarizing this topic, we voice for quality in waterproofing, right? So maybe still, Heiko, I think we still had an interesting or important question to you that is worth some further investigation. So somebody was asking about mosquitoes. So we very funny. We also had this question in a Sponge City masterclass with Concha and you recently in Porto. So it worries people. If it's about water, what comes first is mosquitoes. So do you have some thoughts to share?
First of all, I mean, it's of course it's an issue here too. I mean, we have problems with invasive species here. Mosquitoes we didn't have a couple of years ago, which are spreading diseases. Yeah, but I mean, if you well-designed stormwater management systems have no problems with mosquitoes. So that's what Oscar said. If they dry out in a certain time, that's not a habitat for mosquitoes. Mosquitoes need, for example, water which stays in a pond for a couple of days or several weeks. So if a green roof or a bioretention swale dries out within a couple of hours, then it's not a problem. And when you have systems, for example, I have a big pond in my yard, and I have no problems with mosquitoes because there are a lot of frogs in there, and it's not a good habitat for mosquitoes, in fact. So we have no problems with that.
This is a nice concluding answer. Make sure you got space for the frogs. Then the mosquitoes are not your primary concern.
To be honest, the bigger problem I personally have is the problem with the noise coming from the frogs. Yeah, especially in May and June. You cannot have an open window at night. Well, but if you don't like that, you shouldn't have an open pond.
Well, yes, concluding, of course, green roofs and walls also have a very strong performance in relation to noise and sound. So it's always a good idea to invest into these kind of technologies. I see that Tiana has already opened her screen. This means we are running out of time. Thanks for reminding us. And yes, I would like then to conclude today's webinar with a few maybe words from our two participants first. And once it's concluded, we're going to give it a date the topics of the next webinar and definitely wrap up. So I've asked my two speakers to conclude one sentence that they would advise our participants with in relation to stormwater management. Heiko, you go first.
Yeah, well, I mean, we have a lot of experience now in the field of stormwater management. It's not a single technology. Use all the different technologies which are available and combine them in a proper way. That's usually the most effective way of dealing with stormwater. And by the way, it's also a lot of fun because no project is like the other. So it's very interesting.
Thank you, Heiko. Oskar, your advice to our audience.
Well, similar to what Heiko was saying, because every project is different. I think by putting these projects through a simulator and looking at these with the help of a model, it really allows you to add a lot of intellect to the design of the system and kind of go away from a commodity approach to a much more specialized, specific performance-driven approach. And it offers more margin and quite frankly, a better end result for everybody involved.
Thank you both for your great inputs today. Summarizing, I think there is a moment for stormwater management currently. A lot of directions and policies are actually already in place. Still on national levels, I can see a bit of a disparity sometimes in terms of existing policy and also laws that are at the very moment not 100% in favor of stormwater management and especially also water treatment by nature-based solutions. So I think this is, yes, the upcoming 10, 15 years. And yes, a lot of works, and just like Heiko said, great and interesting projects are waiting for us, especially also when it comes to refurbishing our building stock. Yes, so what's up? Upcoming events, something very important and recent from today. Today we have launched our open consultation on the Nature Positive Economy paper that the EFB, together with a lot of other project partners, has been part of. So please visit our website of the project and give us your feedback. So what we do is we want to build a nature positive economy in Europe. We are trying to find out how we can do that, also for the building industry side of the economy. So if you're a policy, public sector person, a business, including SMEs, a nature-based enterprise, a finance investor, environmental NGO, citizen community group, research organization, or a standardization body, please click the link, look at our concept, and let us know if you find it good. As a next step, after the consultation phase is over, we are going to develop related key performance indicators and processes, whether to assess how nature positive and nature negative a company, a project, a product, etc. is. Yes, another upcoming event, 30th of October 2024, we have a European update meeting again from the EFB side. It's open to our members and members of members. Please feel invited. Of course, this time we are going to look at important European developments. Luigi Petito and Egbert Rosen will be present again from World Green Infrastructure Network and ELCA. We will be looking a bit deeper on this concept of nature positivity during the European Update meeting. And we're also going to look at a very specific and great example of an urban living lab for green roofs in the UK. So I also invite you to participate. I think it's going to be fun. Our next webinar will be on green roof solutions for retrofitting. So what are we going to do with all this building stock we have? We need to be precise. 27th of November, you can expect interesting talks from Paulo Palha, Dusty Getch, and Rebecca Landwehr, who will be talking about their greatest refurbishment project. Last but not least, 2025, the World Green Roof and Green Facade Congress in Basel. Maybe you as well find the time to join us there, not just online, but also on site and visit some of the great biodiversity-oriented green roofs of the cities. So that's maybe quite a good, place where we could also meet in person soon. Thanks a lot. I hope I did not forget anything. Again, our thanks to Ecostratos and Sempergreen for sponsoring today's webinar. Like Tatjana said in the beginning, it's recorded. It will be online very soon. And yes, we invite everybody to rewatch it. And in case you still got unanswered questions, or you want to get in touch with us, or you get the presentation, please send an email to office@efb-greenroof.eu. And yes, we will put you in contact. Thanks again, Heiko. Thanks again, Oscar. You've been great speakers.